Namaskar, I am Gopal Chandra Khan. So today let's learn logarithm. Okay, so logarithm is a very important part. Actually, from where this logarithm is coming, let me show you. Look, we know 2 to the power 4 equals to 16, right? Even we know 3 to the power 3 equals to 27. Like all these things calculation, there is a very shortcut system actually it can give us, that is actually what? Logarithm. What we can get from here? Logarithm 16 base 2 equals to 4. Now similarly in this case what you can get? Logarithm 27 base 3 equals to 3. Okay, let me show how things are coming. Let us take two things. One is A, another is M. Both are greater than 0, means they are positive. Like 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, more than 0. 0 se zyada hai, okay? Like some, they are having positive values. And we are getting some x like that. A to the power x equals to m, okay? A to the power x equals to m. So if we get like that, we can write what? Logarithm, we write in short log m base a equals to x. Actually we know this one from indices, and from indices we know, from there we are getting what? Logarithm m is here, base a here, and power of a is coming here is the value. That means simply, suppose we see here 2 to the power 4 equal to 16, that means 16 is acting like m here, it's coming here, and this 2 is coming as here base, and the power is becoming the value of this logarithm 16 base 2. Okay, let me show some more example like that. So you can tell many more example just like that we can take. Suppose you have 4 to the power half equals to what value we get? 2, right? That means from here we can get, actually the formula is a to the power x equals to m, that giving us log m base a equals to x. We are always using that one. So from that calculation what we are getting? Logarithm 2, these two taken here, okay, base 4 equals to half. Okay, see this value and this value always taken positive, but this value can be negative also. Let me show one more example. Suppose 3 to the power minus 4, what we know? Equals to, from that calculation we know 1 by 3 to the power 4, means we are getting 1 by 81. This is positive or not? Yes, this is positive. This value is positive or not? Yes, this value is positive. That means you got 3 to the power minus 4 equals to directly 1 by 81. Now you can take logarithm here 1 by 81, this is coming from here, and this 3 is coming as base, and the value is coming here minus 4. Check, this is plus, this is plus, but you got the value minus. So it can happen like that. Okay, so we are actually getting some relation from the indices that will help us to solve many problems like multiplication, like subtraction, like many more, finding root, okay, finding to the powers higher index, all those things it will help us in logarithm. So that means main formula we are getting from here only. Okay, now see, if we take a to the power 0 equals to what we are getting? 1. A is any value, you are getting a to the power 0 equal to 1. So can I take from logarithm formula 1 base a equals to 0? Look here, x is 0, okay, here m is what, 1, so 1 is taken here. That means this 0 is coming here and this a is coming here. So log 1 base a equals to 0. So one formula we got, logarithm 1 base a equals to 0. Next, suppose you have a to the power 1 equals to a to the power 1 equals to a. Now from that logarithm system, can we write a base a equals to 1? This a is coming here and this a is coming here as a base. And now you got another formula, number 2, logarithm a base a equals to 1. Okay, now see, if I get a to the power minus 1, we are getting 1 by a. That time what will get, logarithm 1 by a base a equals to what, minus 1. Here also this is coming as m, okay, and this a is coming as here base. So now you got another formula, number 3, logarithm 1 by a base a equals to minus 1. Okay, now let me see, if a to the power, see, this is not the only cases, many cases we can write this x value, you are getting this. Now can I just take this x value, can put here, let me show you. So here you are getting how, you got this, you are getting like that, a to the power x equals to m, right? Now from here you are getting by the formula log m base a equals to x. Now this x value is this, am I correct? Now इसको इधर लगा दो, put it here. That means what you are getting, we are getting a to the power log m base a. Look here, this to the power, if I take it ground floor, it is first floor, it is a second floor, okay, but you have to maintain these things, and value you are getting what, that is equals to m, because we are replacing here only, this x value is that one, I replace, nothing more than that. So now can I write a to the power logarithm m base a equals to m, another formula. Okay, now see, you are getting all this formula by understanding from the indices. So indices actually is helping us to get these things. So that indices you have to know, because this is a basic platform. Okay, suppose your class is on third floor, this class is on third floor. Now second floor is not there, third floor, first floor is not there, ground floor is not there, you cannot stay. Third floor cannot float like that. Okay, so Gurutva Akarshan ball, that means gravitational force is there, it will come down. Okay, so it cannot float like that. So here you have to understand the indices, from here you are getting these things. Now the most important formula which we use again and again, that is what, that formula is logarithm m base mn base a equals to log m base a plus log n base a. Let me show you. Let us take a to the power x equals to m, that gives you what, log m base a equals to x. It's number 1, and you are taking a to the power y equals to n, that will give from the formula log n base a equals to y, that is number 2. Now if I multiply these two, so can I write a to the power x into a to the power y equals to m into n? These two we are multiplying, left side, right side, multiplication done. Now what you are getting, a to the power x plus y by that indices rule equals to mn. Now see, if I do use the logarithm same formula, now can I take, this is actually like acting like m, So here you are getting logarithm mn, this base a is coming here equals to x plus y, and when I take x plus y, this x value can I replace by this? That means logarithm m base a from here, and the y value actually y value will replace this equals to what? Now logarithm n base a. That means you got the formula number 5 formula, that logarithm m into n base a equals to logarithm m base a plus logarithm n base a. That means you got the fifth formula. Similarly, if I try to do the same way, if I try to do that m by n, so we will get what? Minus. Let me show you. We shall do same way. We shall take a to the power x equal to m, that will be log m base a equal to x, a to the power y equal to n, log n base a equals to y. Same as it is. But here we shall do divide. If I divide, it will also divide. Yes, that means a to the power x by a to the power y equals to m by n. That means here it will be m by n and here it will be minus. Because change ho gaya, it is changed already. Okay. Now, if I see this is minus, that means what? From that formula, if I take log m by n, we are getting what? Only minus here. And if I replace all other values, we are getting what? Only minus here. That means another formula we found, what is this? Logarithm m by n base a equals to log m base a minus log n base a. Now all those things I have given some formulas. I have to show them also that how the application of the formula, how this we are applying. Okay, another formula is there we can apply. I hope this is clear. Okay, I am going little fast, but as it is being recorded, you can repeat it, no problem. Okay, otherwise it will be too much tall. Okay, too much long video. Okay, let me show. If I want to do another thing, another calculation, like suppose you have same a to the power x equals to m. That means from that formula we got what? Log m base a equals to x. My dear, this is the basic things. Now we are taking a to the power x whole to the power n. I am taking power whole to the power n, means 3 to the power 3 to the power 4 to the power 5, like that. So what you are getting? Equals to, of course here also you will get m to the power n. Am I correct? This whole to the power n also it will be whole to the power n. Now if it happens like that, by indices calculation n into x will be multiplied, and here it will be m to the power n as it is. ये m to the power n ही रहेगा. Now if I take logarithm both side, by that logarithm formula, this one if I apply, what it will give you? Now it will give you n, it will give you logarithm m to the power n. This is coming here as m, and base equals to a equals to n into x. This power is coming here as n into x. N is coming as a multiplier. Okay. Now can I write logarithm m to the power n base a equals to n into this x value? Can I take this one? Sure. That means we are getting logarithm m base a here, because the x value, this x and this x same, this value replaced here. That means we got another formula we can write here, that is I can write in the left side corner, that is number 6. We are getting what formula? Logarithm m to the power n base a equals to n logarithm n base a. Now see, all this formula I told. One more thing I'll tell after that. That formula you have, I'm writing here the formula. After that I'm proofing this one. Log a base b equals to, you get log a base c into log c base b. How we can prove this? Let logarithm a base b equals to x and logarithm a base c equals to y and logarithm c base b equals to z. Look, if I can take a to the power x equal to m, of course I am getting logarithm m base a equals to x. So now if I want to take reverse, opposite direction, actually from here to there, that means a to the power x equals to m. So in that way, can I write b to the power, this b is a base, this x is a power, equals to what? A. Look at this. Log a base b equals to x. So and here what you are getting? Same way you can take c to the power y equals to a, and here you are getting b to the power z equals to c. I repeat this one, b to the power x equals to a. Students, you please see this one very calm and quietly. If you want, you take a pause. Here you want take a pause. See, b to the power x, c to the power y. That's why c to the power y. Because here look at this, a to the power x equals to m. This m is coming here, right? Similarly, here also b to the power z is coming here equals to c. Now, if I replace them, how it will come? Look here, you are getting b to the power x equal to a, c to the power y equal to c to the power y equal to, yes, c to the power y equals to, also we are getting a. Now see, you are getting b to the power x equals to c to the power y, yes or no? From this and this, can I write, because the a equals to b to the power x, a equals to c to the power y, तो a को छोड़ दो, leave them a. So you are getting left side taking here. Now see, if you get this, so from these two we are getting this one. Now here c value, what is this here? C value equal to b to the power z. So can I replace this c value here? Yes, I can replace b to the power x, leave it here, but here in place of c I am writing b to the power z whole to the power y. Because I have taken c value equals to b to the power z, I am putting in place of c b to the power z. That means last final what you are getting? Final you are getting, that implies b to the power x equals to b to the power yz. These two are multiplying, because this is the rule of indices, right? Now b to the power x, b to the power yz, can I take x equals to yz? Now what I have taken? What is this here? X equals to, just put the values, what? Logarithm a base b. What is the y value here? Logarithm what? A base c into z value is what? Logarithm c base b. See, that means what we came to know, that when this one thing will be just same, you can just omit it, and upper one will be as logarithm and this lower one will be as base. That means logarithm a base b. You are getting this. Now this formula established. Okay. So once more I repeat, what we will do? Let this equals to x, this equals to y, and this equal to z, right? If I take like that, just do the calculation from indices, because you have to always take the help of indices, because indices is playing a big role here. If you don't take the indices, you cannot do. Okay, indices का help लेना ही पड़ेगा, you have to take it, right? So here you see, I have taken From here reverse I have taken b to the power x equal to a, c to the power y equals to a, and b to the power z equal to c, and I found a equal to this, also a equal to this. That means this both a, if I don't take, so you are getting this equal to this, mane Rama equal to Sama, okay, and again Sama equals to Krishna, okay. So then Sama you can deduct, okay. So like that we can do, huh? So Rama equal to Krishna you are getting, Rama equal to Sama, okay, and Sama equal to Krishna, okay. That means Rama equal to Krishna we can take like that, okay. We are getting this way, okay. Now C value we are putting where? C value we are putting in place of this, because if I replace C value, that is with B. Now slowly look at this B also, this B also actually removed, okay. By the indices rule we are getting x equal to yz. All these things all taken actually, this in logarithm part all are positive value, okay. So you are getting x equal to yz, and now you got the proof, okay. I hope it's clear. Now let me show the application of all, because only the formula you got and I showed you the theorem part only, and now let me show you that actually practical use of them, okay, how we can apply. Now first I will show you number one application. Number one, what? Logarithm 1 base a equals to 0. If I apply this, so can I take logarithm 1 base 5 equals to 0? Yes, okay. Number two, if I want to do this one, if you get logarithm 5 base 5, can I write equal to 1? Yes. So 1 is done, number 2 is done. Now let me show number 3. Number 3, okay. So in number 3 what we are doing, that is in number 3 what we are doing, logarithm you got suppose 1 by 5 base 5. That time what is this? Here is 5. If you do that way also calculation, 5 is here, 5 to the power minus 1, okay. And you are getting, if you try to apply this 6 formula also, you are getting what? Minus 1 outside log 5 base 5, again minus 1 into 1, again this number 2 applied, and you are getting minus 1. And see, if you do this directly minus 1, this application number 3 also done. So no need to do so much of calculation. If you know this, that this comes minus 1, directly you can come from here to minus 1, okay. Now next I can show you, that is what? Number 4. What is this number 4? Number 4, if you get sometime logarithm, suppose 5 base 2, actually is 2 to the power log 5 base 2, okay. You are getting like that, log 2 to the power logarithm 5 base 2. When this and this matching, you can get the value only 5. Sir, if it is not 5, if it is 50, that time it will be 50. If it is 12, it is 12 and it is 50, yes, it is 50, because it won't change. Now suppose you have 3 to the power logarithm, suppose 10 base 3, that value also will give you 10. Look, this 3 is actually just matching, it is not changing the value of this, so you are getting only 10. I hope it's clear to you. Okay, now this actually number 4 application done. Number 5, so how we can do? We can get many calculation like log 50. I need to get the value of log 50. Suppose base is here 10. So I can get what? Log 5 into 2 into 5. Look at this. 5 into 10, 10 into 5. How much? 50. Base 10. So I can write logarithm 5 base 10 plus log 2 base 10 plus log 5 base 10. I hope it's clear to you all. Okay. See, I can break because of the multiplication, this becoming plus plus plus. Many times we do calculation and here we can apply this and it will help us to simplify a big calculation. Okay, here we will get. Now let me show you that number 6, this one. If you get sometime log, suppose you have 25 by 12 base 2. How we can do calculation? We can do calculation like that: logarithm 25 base 2 minus logarithm 12 base 2. After that, whatever calculation you are getting, you can go ahead with this. Even 12 also can break 2 into 3, 25 you can break it 5 to the power 2. Okay, so like that way you can go ahead. Okay, look, you can finish this calculation. So that I'll come in the next part, second part. So you got the application of 6 also. Now done. Now we are coming to actually it's supposed to be 7, it's supposed to be 8. It's okay, no problem. So here the 7 we are getting. How? Suppose you have logarithm 2 to the power 5 base here 3. So you can do calculation, 5 will come left side, log 2 base 3, or else any other calculation like logarithm base here 5 and here you got sometime 5 to the power 3. That time this 3 will come here, log 5 base 5. Now see this value from number 2, you can apply 3 into 1 and it will become 3. So it will help us that power will be as a multiplier of this logarithm 5 base 5. Now you know this value, this into this 3, it's come here. That it help us to get easy values. Now many times that number 8, how we can apply? Now many times you will get logarithm, suppose you will get 50 base 10, okay, into logarithm 10 base 20 into logarithm 20 base 50. Now you need to do calculation. So how will do this calculation? First, if you look at this, what is common here? Look, 10 and 10 common. So by using this formula, actually from this to this, also from here to there I can write. So this like C, here C and C matching, here 10 and matching. Can I write log 50 base 20, okay? And you are getting the next log 20 base 50. Now here also you are getting same 20 and 20 matching, you are getting what? Log 50 base 50 remaining. Last, these two cancel and you are getting what? Only 1 now. And you know what formula I applied? Number 2. So all around 8 main formulas are there. We always use them, and from there all these things we can do. Okay. So many more things are there, applications also there, and log tables also there. Everything will come to know. So you like it, comment it, what next chapter you want, know what next topic you want. Okay, and as much as you can do, share with your friends, with your brothers, sisters, or any others, that they can also get help from here. So thank you. We'll meet with the next topic next day. Bye.